In this lecture, moving on to the Marshall mixture design method. So the overall procedure for the mix design always begins with the acceptance tests performed on the aggregates and the bitumen considered for the design. That is, for the selection of aggregates, so these are the some common tests that you have to perform, where based on the specified values you have to check the aggregates, that is if the acceptance test on the aggregates as well as the bitumen pass, then the mix design can be completed using the Marshall procedure. And the procedure that follows is appropriate for the mixture using that grade of bitumen used with the aggregate size and the gradation. So these are the tests for aggregates, and these are the certain tests for the bitumen. So earlier I have given you the details of the test for the aggregate as well as bitumen. So there are some common tests that are required for the bitumen as well as there are some tests for the aggregate. So which have to comply that values provided for that VG grade, VG 10, 20, 30, 40. So the bituminous material value after testing should be within that range. So now moving on to the steps. So the first step after means the bituminous material as well as the aggregate tests. So the first step is the selection of proper aggregate gradation, that is depending upon the requirement, means what type of layer we are going to construct, that it is a bituminous concrete layer or it is a dense bituminous mix layer. So which layer property we want to use, that we have to select first, then we have to select the gradation based on the thickness of the layer. So as well as here the specific gravity of aggregate and the specific gravity of bitumen are computed using the standard procedure. So based on the aggregate test, certain tests are used for the quality of your aggregate and the quality of bitumen. Among them, the specific gravity test is vital for the mix design calculation. So after the selection of aggregate, next is the mixing and compaction temperature. So basically the mixing and compaction temperature, it can be selected from the chart provided by the IRC code, that is based on the VG grade. But the other procedure is how to determine the range of that mixing and compaction temperature. So there is a temperature viscosity plot that is provided, where that is the mixing temperature should be selected to provide a viscosity of 170 plus minus 20 centistrokes, as well as the compaction temperature should be selected to provide a viscosity of 280 plus minus 30 centistrokes. So based on the viscosity value, the mixing temperature and compaction temperature are selected. But as the IRC has provided certain values and ranges, so we can choose from that values. So next, after selection of the mixing and compaction temperature, so it is the process we have to follow for the preparation of test specimen. Okay, so the Marshall specimen are prepared at different bitumen content, means we have to first make a trial bitumen content, means suppose we have considered 3 bitumen content value, 5%, 6%, 7%. So as per the MORTH code, every gradation they have given a certain bitumen content value. But what happens here, that the aggregate quality varies from every location to location. So what happens, suppose they have provided a mix design in that based on the gradation they have provided a value of say 5.9. But when we are doing with our type of aggregate within our laboratory conditions, we have found that the OMC comes near to 6.3. It may happen. So we have to select at least 3 different bitumen content to plot a graph as well as for exact calculation of the optimum bitumen content. Next thing is, based on the selection of quantity of bitumen, our aggregate samples are sorted. So the total overall weight of the bituminous mix, that is aggregate as well as bitumen. So both the mix weight is 1200 gram based on the specimen that is used. And after preparation of the specimen at mixing temperature, the compaction is achieved by using the impact compactor by applying 75 blows on each side, that is basically for the heavy traffic condition. But for the medium and light traffic condition, that number of blows changes, that is 50 and 35. On both are on, all are on the either side, means you have to again rotate the specimen and again apply that, say for heavier one it is 75, for medium 50 and for low 35 blows. So after the compaction you should have to leave that specimen within the mold for at least 24 hours for cooling down of the specimen, or you can say it curing. After that the sample are extracted from the mold and then it is tested for the stability, the bulk density, air void analysis, the VMA, VFB, these are calculated by using formulas. So mainly we have to conduct the test for calculating the bulk density of the mix, and parallelly we can calculate the air void, and the test by using the Marshall method is basically the test for stability and flow. So with that apparatus we can calculate the value of stability and flow. So after getting the values we have to plot certain graph, that is the bitumen content, 3 bitumen content we have selected. So that 3 bitumen content versus stability, again that 3 bitumen content versus flow, then bitumen, the 3 ranges of bitumen content, bulk density with the air void, with the VMA, that is void in mineral aggregate, and VFB, void filled with bitumen. So after plotting them we have to check that at what bitumen content we are getting the maximum stability, we are getting the maximum density, and the bitumen content corresponding to 4% air void is selected. So we have got 3 different bitumen content from 3 different graph, and we have to take the average value of these 3. This is our optimum bitumen content, and that bitumen content we have to check for the condition satisfying the VMA value as well as the VFB values. So this is one example where based on the aggregate gradation is given. Say suppose it is grading 1 and grading 2 for 2 different layer thickness, and based on the sieve size certain values are provided for the percentage passing. So here for the every range of sieve size we have to consider the mid values. So it is 90 to 100, we have to consider 95, then 59 to 79, so we have to consider here the mid value. So considering the mid value we have to check the aggregate gradation first, and that I have earlier told that bitumen content by the mass of total mix minimum 5.2. So as it is 5.2 provided, so we can check it by 5, 5.5 and 6% of bitumen content. So based on that type of gradation we have to check first the criteria that are satisfying. So see, this is one of the example that I have shown you, that the sieve sizes are provided and I have calculated the mid values based on the aggregate gradation range is provided. So what is the utility of that? Means here mid values are provided, so from that we can calculate the retained value. So these are the mid value for percentage passing. So we have to calculate the retained value. So how we calculate? That is, here 100% is passing, means 0% retained. Here 95% is passing. So that means 100 minus 95, that is equivalent to 5. So 5% is the retained value. Then for the next sieve, means on 9.5, it is 95 minus 79. So here 16% is the percentage retained. So parallelly we have to minus from this to this, this to this. So and we can calculate the percentage retained value. So we have found the percentage retained value. Then based on the bitumen content, suppose earlier I have told that 1200 gram is my total weight of the mix. So if I choose 5% of bitumen, so for 1200 gram 5% of bitumen is 60 gram of bitumen. So 60 gram of bitumen I have selected. So if I have selected 60 gram of bitumen, then from 1200 gram if I would subtract that, then the value for aggregate comes 1140. So that should be the weight of aggregate. So considering that 1140 value, we have to distribute the weight retained on that proportion, that is 5% of 1140, 16% of 1140, and based on that, for a particular mix we can calculate the weight of aggregate based on the sieve sizes. So for 6% bitumen, again that value changes, 72 gram of bitumen. So as 72 gram of bitumen is used, then for the aggregate, that is 1200 minus 72, that is the value, and again we have to, based on the retained value, we have to distribute that weight, and parallelly we have to do the mix design. Then these are the process for the preparation of test specimen, where initially the aggregates should be washed so that there should not be any dust or dirt. Then they are properly dried up, and after that you have to calculate the weight of that aggregate based on the gradation, that is the particular sieve sizes, and you have to make certain batches, that is, this is the weight, say it is a 1140 gram weight, then you should have to prepare such bags. Then after that you have to pour them in a one tray and put it in the oven. So here the initial step is heating the required weight of the aggregate to the desired temperature. Then your heating of bitumen is required by the weight of the bituminous binder to the specified temperature. For the different trial binder contents are selected. Okay. Then you should have to, after heating up of the aggregate, you have to put it in a pan where you have to put the bitumen, and again you have to start mixing. So mixing the aggregate and binder in the laboratory mixer at that appropriate mixing temperature is mandatory, depending on the type and grade of the binder used, so that the aggregates are fully coated with the binder. Then you have to transfer that mix to that any tray, and that tray have to put it in the oven for conditioning. So conditioning here is required for proper absorption of the binder by the aggregate. So that conditioning time is basically 2 hours is considered. So after getting the conditioning period, you have to transfer the mix to the mold. So here this is the mold there, and you have to do the compaction as specified by the test method, that is either by 75 or by 50 or by 35. So after that you have to apply, you have to rotate the mold and again apply that compaction. So next step is removing the test specimen from the mold and cooling it to the room temperature. So this is how that it is being removed. So there are two processes, one is by automatic and one is by manual process, where the specimens are moved out, and then for each trial binder content, say I have taken 3 binder content. So for each binder content you have to make at least 3 test specimens, means for a particular mix design you have to do total 9 samples. Okay. Then the next step is determination of the specific gravity as well as the thickness, because that height it is 63.5 approx, and as well as the dia it is 100 to 101. So how much difference is in the height as well as dia is there, you have to calculate. Then you have to calculate the specific gravity of the compacted specimen, so that you can calculate the volume of air void in that mix. And later on you have to put the specimen in a water bath maintaining 60-degree temperature for 30 minutes. Okay. So that is the initial procedure, that putting up the samples in a hot water bath for 30 minutes for the Marshall stability test on the bituminous mixes. So this is the Marshall test setup, where you have to put the specimen in the mold and a certain load is applied. So you have to calculate here, that is the basically the load value, that how much load it can carry for the cracking it is occurring. So the Marshall stability test is conducted on that compacted cylindrical specimen of say dia 101.6 millimeter and thickness 63.5 millimeter. The load is applied, basically the load is applied perpendicular to the axis of cylindrical specimen through the testing head that consists of a pair of cylindrical segment, where a constant rate of deformation of 51 millimeter per minute is done. So Marshall stability of the bituminous mixes is basically a maximum load carried in say kg or kilonewton at the standard test temperature of 60 degree when the load is applied under the specific test conditions. So here we can calculate the stability value as well as the flow value. So flow value is basically the total deformation of that Marshall test specimen that undergoes at maximum load, and that flow value is expressed in millimeter. The stability is expressed in kg or kilonewton, the flow value is expressed in millimeter. And these are the certain values for check that I have earlier told, that based on your bitumen content you have to check the VFA value is within the range or not, your VMA value is within the range or not. After that you have to plot that graph that is based on the bitumen content. You have to plot for the stability value, means at 3 different bitumen content you can get the 3 stability values. Then you can get the bulk density values, 3 air void values, 3 VMA value, 3 VFA value. So you have to pick the maximum stability. Say at 5% of bitumen content I am getting my maximum stability. Okay. Then maximum density I can achieve at approx 5.5. Then what is the bitumen content at 4% air void? So at that 4% air void it is approx 5.4. So my optimum bitumen content is 5% for stability, 5.5 for bitumen content and 5.4 for air void content. So the average of these three, 5 plus 5.5 plus 5.4 divided by 3, that is my optimum bitumen content. Then that bitumen content you have to check for the flow value, the VMA value and VFA value. So this is the overall procedure for the Marshall mix design. So these are the experimental procedure, but for the calculation wise, that is the important thing is the weight volume relationship. So that is the very important to understand here, that during conduct of mix design and quality control assurance in the field, so that the analysis of volumetric property of an asphalt mix is of primary purpose. So and that properties are dependent on the three important parameters basically in controlling the quality of the design mix are the percent of air void in the total mix, the percentage of voids in mineral aggregate and the percentage of void filled with bitumen, that is the VFB, VMA and the VA, voids in mineral aggregate. So in this PDF you can find that there are certain formulas provided. So these formulas are mainly required for your say GATE exam, because in your university exam based on the formula the numerical doesn't come, but for the GATE oriented purpose you have to remember these formulas. Like here is the theoretical specific gravity of the mix. So generally we calculate the specific gravity of the aggregate, bitumen. So here combined way it is the theoretical specific gravity of the mix, where a formula is there. So that W1, W2, W3 and WV. So W1 is the coarse aggregate in the total mix, the percentage, that is I have taken that is the 1200 gram. So in 1200 gram what is the my percentage of or the weight of coarse aggregate in the total mix. W2 is the weight of fine aggregate, W3 is the weight of filler particle, the dust particle, and WB is the weight of bitumen. So based on that weight calculation, that G1, G2, G3, G and GB, these are the specific gravities, and calculating this we can calculate the theoretical specific gravity. Then comes the bulk specific gravity of mix. So that is calculated by that formula, okay, where Wm is the weight of the mix and W is the weight of mix in water and there the difference. So that is the simple step for calculating here the air void, that is weight in air, weight in water, that factor. Then based on that we can calculate the air voids and later on the percentage volume of bitumen. Okay, so percentage of bitumen and percentage volume of bitumen is different here. Next the important thing, that is the VMA and VFB. So void in mineral aggregate. So the volume of the void space between the aggregate particles of a compacted paving mix, means after compaction there are certain voids present. So this the volume of void. So this volume includes the volume of air void in between the coated asphalt particle plus the volume of effective asphalt. So effective asphalt is that bitumen not absorbed in the aggregate. Okay. Then is the void filled with bitumen. It is basically the percent of the volume of VMA that is filled with bitumen. So basically this is equal to the volume of the effective asphalt by the the volume of bitumen by the VMA value. So at last you have to check these values, because basically VMA, that is the total volume of void within the mass of the compacted aggregate, So if VMA is too small or less, the mix may suffer durability problems, and if that value, the VMA value, is too high, then the mix may show stability problem and it will be uneconomical to produce. So basically the procedure we are following is as per the Asphalt Institute method. So here the design bitumen content of the bituminous mix is to be selected by considering the stability, flow and the air void criteria. So as an initial starting point, the Asphalt Institute recommends choosing the bitumen content at the median of the percent of air void limits, so which is 4%, and afterwards we have to check the criterias that are meeting or not. So for instance, like this numerical once comes in the gate, that in the Marshall method of mix design, the coarse aggregate, fine aggregate, filler and bitumen having respective specific gravities of these values, the specific gravity values are provided and the mix weight are provided, the percentages are provided. So you have to calculate the specific gravity of mix. So that is the first formula that I am talking about, that is your W1 plus W2 plus W3 plus WB divided by the ratio, that is W1 by your specific gravity, W2 by specific gravity, W3 by specific gravity plus WB by the GB, the specific gravity, and that value, that is what should be the value, that is your the specific gravity of the mix. Then in the next question, say it is there a Marshall specimen is prepared for bituminous concrete with a bitumen content of 5%. Okay, so here bitumen content is 5% provided. The theoretical measured unit weight are 2.442 and 2.345 respectively. Okay, the bitumen has a specific gravity of 1.02. Then the percentage in the mineral aggregate filled with bitumen, the percentage voids in mineral aggregate filled with bitumen are. So here basically the theoretical and the measured values are provided. So we have to calculate first, that is the air void. We can easily calculate the theoretical as well as the measured unit weights are provided here basically. So the formula, that is GT minus GM by GT into 100. So by that we can calculate the VV. Then we can calculate the volume of bitumen. We have to calculate. Why we have to calculate the volume of bitumen? Because for calculating the VFB, that is the formula 100 into VB by VMA. Okay, so we have to calculate first the VB for the calculation. Okay, so VB comes by the formula, that is GM into WB by GB. So we know that your GM is provided 2.345 into WB, that is the weight of bitumen, 5% it is given, and GB, that is the specific gravity of bitumen. So we can calculate the VB value from there.